Dear students of class first year, Assalamu alaikum. This is chemistry grade 11 and today we are going to discuss another topic, and the topic is ionization energy. This is topic number 2.6. Students, first of all we define ionization energy. The minimum amount of energy that is needed to remove the outermost electron or the most loosely bounded electron from the gaseous isolated atom is called ionization energy. What is meant by gaseous and isolated atom? This is the single atom of an element that is obtained by melting an element and then heating again to evaporate it. After its evaporation, its atoms get isolated, and after that we are able to remove an electron or more than one electrons from its outermost shell. Here there is an example of sodium. Sodium is an isolated atom. It is in gaseous state, is shown by the symbol G, and when we provide it energy, and this amount of energy is equal to 496 kilojoule per mole of energy, then the sodium converts into a sodium ion and one electron is released. Why one electron is released? This is because there is only one electron in the outermost shell of the sodium atom, so we get one electron and sodium ion. Another example is magnesium. Magnesium is present in group number 2 of the periodic table. It contains 2 electrons in its outermost shell, but when we give it 736 kilojoule energy to this atom, then only one electron is released and we get a magnesium plus 1 ion. Remember that there are 2 electrons in the valence shell of magnesium, so we are able to remove 2 electrons. Now atom is needed to be in the gaseous state to avoid the influence of other factors like heat of fusion, bond dissociation energy, and heat of vaporization. The question arises why the atom should be in gaseous and isolated state. We discuss here the reason behind it, and the reason is that there are so many factors which can affect the bond energy of the atom. The first factor is heat of fusion, because heat of fusion means the heat that is required to melt a substance. So if we don't have an atom in gaseous state, instead it is in the solid state, then the heat which we gave to that atom or that element, that will be utilized in fusion. Similarly, bond dissociation energy, there is metallic bond between the atoms of a metal, so when we give heat to a solid metal, then it will be consumed in bond dissociation or breaking up the bonds. So our answer will be wrong, or it will be a different one. Similarly, heat of vaporization, sometime we have an element in liquid state, and in that state when we give or we provide heat, that heat will be consumed in its vaporization, which is called heat of its vaporization. In fact, for example, if a substance needs only 700 kilojoule energy and it is not in gaseous state, then we will have to provide more than 700 kilojoule energy. That energy will be consumed in fusion, in dissociation, as well as in vaporization. Therefore, the atom must be in gaseous and isolated atom. Now we discuss the periodic trends of ionization energy. Remember that the ionization energy increases from left to right in a period, and it decreases down the group in a group. You know that a periodic table consists of periods which are from left to right, and groups which are from top to bottom. So when we move from left to right in a period, the ionization energy generally increases, and when we move from top to bottom in a group, then generally it decreases. But there are so many factors which may affect the ionization energies, and the trend may not be regular, as we will see here. Ionization energies generally increases from left to right in a periodic table with slight anomalies. Anomalies means that there will be some elements which we might expect to have more ionization energy, but instead they will have less ionization energy. There are so many factors which affect such kind of anomalies. Now we discuss the reasons. The reason is that this is due to the increased number of protons in each step, which strengthen the attraction of nucleus on the electrons. When we move from left to right, the number of protons in the nuclei increases, which have greater pull upon the electrons, so the removal of these electrons become difficult. That is why the ionization energy generally increases. The electronic configuration also affects the ionization energy. For example, in group number 3A, less ionization energies are absorbed, as there is only one electron in p orbital, which is an unstable electronic configuration. Students, we will see that in group number 3A of the periodic table, we need less amount of energy. Why we need less amount of energy? That is because they have one electron in their p orbital, and since p orbital is higher in energy, that is why the electron already have higher amount of energy, that is more energetic, and for the removal of that electron we need less amount of energy. Similarly, instead in group number 5A, greater ionization energy values are observed. This is due to the half-filled p orbitals. Students, in group number 5A of the periodic table, we see that there are 3 electrons in their p orbitals. The 3 electron means that p orbital is half-filled, and half-filled orbitals are more stable. Their electrons have lesser energy. That is why they will need more amount of energy to be removed. That is why the p orbital which have 3 electrons, they will require more amount of energy. From left to right in the main group, the elements shielding effect remains constant, so there is no effect on the ionization energy values in this respect. Students, you know that there are same number of shells in a given period in all atoms or in all elements. Since they have same number of shells, that is why their shielding effect is same, and it means that there is no influence of shielding effect upon the ionization energy in a given period. The atomic radius decreases from left to right, which brings the electrons near to the nucleus. Thus the electron attraction is increased, and so does the ionization energy. Students, when we move from left to right, the atomic radius decreases. This brings the electrons closer to the nucleus, and when they come close to the nucleus, their removal become difficult, so the ionization energy is increases. And now we discuss the ionization energy along the groups from top to bottom. In a group from top to bottom, the ionization energy generally decreases. Students, from top to bottom in a group, the ionization energies are decreased. We will discuss the reasons behind it. As the atom becomes bigger and the valence electrons go away from the nucleus, the shielding effect keeps on increasing, so it is easier to remove the valence shell electrons.